The topic for discussion in this video lecture is about the kinematics, robokinematics, where we involve a Danawit-Hattenberg convention, shortly called as DH convention. And this is Dr. S. Lakshmi, Professor and Head Department of ECE from Rohini College of Engineering and Technology. And on completion, the student will be able to identify the parameters of transform, preferably used in homogeneous transform, and they'll be able to explain the procedure involved in this convention, and they'll be able to understand what the frame is, and they'll be able to assign the frames. And the DH convention. So the idea is to represent each homogeneous transform matrix, which is AI, as a product. So you could see here AI, which is actually given as, which is equal to, we involve two translations. One is rotation, the other one is translation. So rotation is of course we know it is a rotating aspect, whereas the translation is a linear movement. That is rotation and the linear movement. And here the parameters of this transform are known as, so are defined as link length, which is defined or denoted as AI, the link twist, which is denoted as AJ or D, link offset, which is theta, and we have the link angle. So actually AI is a link twist, DR is a link offset, and theta is the link angle. And what are the conditions for existing of these four parameters? So the first one, that is the DH1, the axis X is perpendicular, X1 say for example, it should be perpendicular to the axis Z0, and the axis X1, it should intersect the axis Z0. These two existence of should be considered when you are going to define or give conditions or comments for the parameters. And how do we assign the frames using this DH convention? So say for example we are given a robo manipulator, okay, and we have some n revolute and prismatic joints. N revolute and prismatic joints will be there, or prismatic joints, whatever be. The number of links will be always, it is n plus 1. The task is to define the coordinate frames for each link so that the transformation between frames can be written in DH convention. So the algorithm of assigning these n plus 1 frames for n plus 1 links. Suppose I have 3 links, then I have to assign 3 frames. So this treats separately first n frames and the last one, which is an end effector frame. And it is recursive in first part so that it is generic. So the step 1, so how to choose the Z axis? So we have to choose the Z0 axis along the actuation line of the first link. And second thing is, we have to choose the Z1 axis along the actuation line of the second link. So for the first link, the axis chosen is Z0. For the second link, the axis chosen along the Z is Z1. And similarly, we need to take how many ever links are there. We need to identify or choose the Zn minus 1 axis. This is the step 1. And once these things are over, that is, we need to finish the job and assign a point on each of the Zi axis. That will be the origin of the ith frame. So xi axis for each frame, so that two DH conditions hold. So DH1, as we discussed already, the axis x1 is perpendicular to the axis Z0. DH2, the axis x1 intersects the axis Z0. Why axis for each frame. Step 2. This is the choice of x-axis. Suppose we have chosen the I minus 1th frame and we need to proceed with the ith frame. For the ith frame, the z-axis is already fixed. Of course, we know z-axis already fixed. And the dh1, dh2, the x-axis should intersect, that is the zi minus 1, and xi should be perpendicular to zi minus 1, and similarly xi should be perpendicular to zi. Is that possible? So there are three cases. So zi and zi minus 1 are not coplanar, and they are parallel or they intersect. For all these three cases, it is possible. So where the xi will be perpendicular to the zi. And coming here, zi and zi minus 1 are not coplanar, then there is a common perpendicular for both the lines. And it will define new origin. Say we denote it with O, which is OI, and the x-axis for the ith frame. If zi and zi minus 1 are parallel, then there are many common perpendiculars for both the lines. One of them will define new origin and the x-axis for the ith frame. So it is denoted as OI and XI. If zi and zi minus 1 intersect, then there is a vector orthogonal to the plane formed by zi and zi minus 1. So the point of intersection can be a new origin, and the x-axis for the ith frame is the orthogonal to this plane, so which is denoted by y and xi axis. So step 3. So if you already chosen the vectors, then x and the point y for the ith frame, yi can be assigned by, of course this is not that much important, but this is a cross product operation. And you can see the illustration of DH frame over here in this diagram, which is taken from the one of the robotics textbook. So where you can see we have a joint, three joints, that is joint I minus 1, joint I, and joint I plus 1. We have two links, link I and link I minus 1. And you could see here we have the frames here, which is denoted with ith frame, I minus 1 and I minus 2. And assigning the loss frame to the end effector. So for most of the robots, Zn minus 1 and Zn will coincide, so that the transformation between these two frames is done by a translation by dn along the Zn minus 1 axis. And the second transformation will be a rotation by theta about Zn axis. And this is a planar two-link manipulator. We can see we have two links. This is a two-link manipulator where you could see all the DH parameters represented in this figure. Say for theta A, that is the displacement, the rotation angle. Similarly here this are also the link to A2, then theta 2. And this is 3-link. So we can see here 3-link cylindrical manipulator. And again you could see here we have the frame, which is a base frame, which is denoted with x0, y0, z0, and the origin is at o0. And similarly we have a movement here in the second frame. You could see a movement which is denoted with x1, z1, and y1, and the frame movement is denoted by d2. And similarly in the third frame also you can see the thing is given by the linear movement is given by d3. Here we have a particular angle rotation in the between the first base frame and the first frame. And similarly we have the loss frame, which is denoted with x3, y3, and z3. Thank you.